So what I'm going to do now is I'm going to read off the steps for simplifying radicals, and then I'll do a couple of examples with you. When we're simplifying a radical, what you do is you factor the number on the inside of the radical completely. You create what I like to call, or what you've been told is called, a factor tree. Now, what is a factor of something? Yes, terms that multiply to get the original number. Now the tip is to try to use prime numbers to factor. This will make your factor tree shorter if you try to use prime numbers. Think of prime numbers to factor it. Now after you factor a number, you're going to cross it off. You factored it. It's gone. At the end of your factor tree, after you reach all of the prime numbers, you're going to circle any pairs of numbers. You're going to write the pairs of numbers, one representative, on the outside of the radical. Any of the non-pairs, I like to call them leftovers, go on the inside of the radical. If there are more than one number on the outside or inside, you just multiply them together. So let's try it. We have the square root of 90, and we're being asked to simplify this. The reason, before I get too in depth, the reason we simplify radicals instead of just, square rooting 90, is because this number, most square roots, are not terminating decimals. They go on quite a bit, meaning this is no longer an exact value. Anytime we're square rooting something and we write down a decimal instead, we're losing accuracy because this is no longer an exact answer. We're having to round. We're having to cut off some numbers. So leaving it as a radical, as a simplified radical, makes your answer more accurate. And in math, we try to be as accurate as possible. So that's why we do something called simplifying radicals. So let's go ahead, create our factor tree for 90. Somebody give me two numbers that multiply to be 90. 9 and 10. Cross off 90, we factored it. Can 9 be factored? What goes into 9? 3 times 3. We factored 9, cross it out. Can 3 be factored? It can technically into 1 and 3, but this is kind of just repeating another step. 3 is a prime number. We leave it. As soon as we're ending a branch on a prime number, we're done with that branch. So 3 and 3 are set. They're good. They can stay. But 10 still needs to be factored. Into what and what? 5 and 2. Cross off 10. Can we factor 5? Not really. We can factor into 5 and 1, but that's just repeating the same 5 again. So if 5 is prime, 2 is prime, we're done with our factor tree. Are there any pairs of numbers? 3 and 3. Circle the 3's together. Are there any other pairs? there any other pairs of numbers? No. So now we create our square root, our radical. You write one representative for your pairs on the outside of your radical. So I'm writing a single 3 on the outside. Then I take my leftovers and I write them on the inside of my radical. And if there's more than one, what do you do to them? You multiply them. So what is 5 times 2? 10. So my simplified radical is 3 square root 10. That's as simplified as it gets. Does anyone know what we're technically doing here? What are we actually pulling out of our square root? What did we actually pull out and then square root? 9. Why did we pull out a 9 and square root it? What is 9? What's special about 9? What is special about square rooting 9? What's special about square rooting 4? What's special about square rooting 16 or 36 or 100? They're what, Eli? They're going to be the same prime number because they are perfect squares. All you're doing here really is pulling out perfect squares. You're pulling out perfect squares and square rooting them. Okay, so let's try 192. This is a harder number. When you get up to the harder numbers, what's the easiest factor you can look for? 2. If it's an even number, like this one is, it ends in a 2, you know that it's divisible by 2. 2 is going to be one of its factors. 2 times what, though? That's the question. 96. And you will have access to a calculator for this whole unit. So if you don't know, you can, in your calculator, divide. Why am I grabbing the actual calculator? You can, in your calculator, divide 192 divided by 2, and you get 96. We factored 192, we cross it out. Should we factor 2 or is it done? It's done. Can we factor 96? What goes into 96? 2 and 48. What goes into 48? 2 and 24. What goes into 24? 2 and 12. What goes into 12? 2 and 6. What goes into 6? 2 and 3. Are we done factoring? Yes. Could we have made a shorter factor tree? Yeah, probably, by not dividing by 2 each time. But it's okay, it works. There's many ways you can create your factor tree, and each one is correct. It's just up to you. Now, do we have any pairs? What are they? We have a pair of 2's. What else do we have? Another pair of 2's. What else do we have? Another pair of 2's. Notice how my last pair of 2's are not next to each other. This is fine. They don't have to be next to each other to be a pair. Okay? So, what goes on the outside of my radical? How many 2's? How many pairs of 2's did we have? 3. So you write 3 2's on the outside. 1 for each pair that you created. 3 2's, but then remember, if there's more than one number, what do you do to them? multiply. So in between the twos, we have multiplication. And then do we have any leftovers? 3. And where do we put that leftover? On the inside. So in the end, what is 2 times 2 times 2? So what is our simplified radical? 8 square root 3. And we're done. Any questions on simplifying radicals? Do you remember doing this in geometry? No. Ava nodded. I saw the nod. It's okay. So your homework for simplifying radicals is just 1, 3, 8, and 12. We'll try 12. Yes. 1, 3, 8, and 12. And then on the previous page, we also had 1 through 3 on page 4. But you've got a bunch of time. You most likely can finish this before the end of class.